In math, it's kind of like going on a journey. Sometimes there's more than one way to get to the right answer. Today, we're going to explore the two main routes for adding mixed numbers. So let's dive right in.
So what do these things have in common? It sounds like the beginning of a riddle, right? But the answer is actually super practical. They all depend on mixed numbers. Just think about it for a second. 1.5 cups of sugar, a 2¼ inch bolt. These numbers are literally all around us.
So let's make sure we're on the same page. What exactly is a mixed number? Well, it's pretty simple, really. It's just a whole number hanging out with a proper fraction, like 4.5. It seems easy enough on its own, right? But the real fun starts when you need to add them together. And that, my friends, is where our journey begins.
And here we are at the Mixed Number Challenge. Because while these numbers are super useful, I get it. Adding them can sometimes feel a little weird. But don't you worry. We are going to break it all down and make it totally clear.
And you might be wondering, why bother with this? Well, it's not just some random math puzzle. Getting good at mixed numbers is a really big deal, a fundamental skill in curricula like Cambridge Lower Secondary. It's like a crucial building block for all the more complex math you're going to run into later.
All right, time to roll up our sleeves. Here's our first problem. We're going to add 4⅛ to 6⅞. This is going to be our test case, the starting point for both of the paths we're about to check out.
Let's start by heading down path 1. I like to call this method separate and conquer. For a lot of people, this is the most intuitive way to go about it, and you'll see why in just a sec.
The logic here is really simple and clean. First, just focus on the big numbers. 4 plus 6, that's 10. Easy. Okay, now let's deal with the fractions. 1/9 plus 4/9 gives us 5/9. The last step, just put them back together. Our answer is 10 5/9. See? Pretty neat.
Okay, that was a bit of a softball, wasn't it? But what happens when the fractions don't play so nice? When they add up to more than 1. Let's crank up the difficulty a bit with one you might see in those Cambridge workbooks. 2 3/5 plus 6 4/5. We're not going to change a thing. We'll follow the exact same steps. First up, the whole numbers. 2 plus 6 gives us 8. Next, the fractions. 3/5 plus 4/5 is 7/5. So if we combine them, we get 8 7/5. Wait a second. That looks a little weird, doesn't it? 7/5?
And you're right to think so. 7/5 is an improper fraction. That means the number on top is bigger than the one on the bottom. We can't just leave it like that. We have to regroup. Think of it like this. How many 5/5 can you pull out of 7/5? Well, just one, right? So we pull out one whole unit and we're left with 2/5. Now we just take that extra 1 and add it to the 8 we already had. And that gives us our final answer, 9 2/5. That regrouping step, that's the whole secret to this method.
Okay, so that was path 1. It works great, but that regrouping step can sometimes trip you up. So is there another way? You bet. Let's explore path 2, the improper fraction way. Now, the strategy here is totally different. We're not separating anything. Instead, we're going to transform the numbers right from the get-go. It's like a 3-step dance. First, convert the mixed numbers into improper fractions. Second, add those together. And third, convert the result back into a mixed number.
Let's go back to our very first problem and run it through this new system. First, 4 1/9 becomes 37/9, and 6 4/9 becomes 58/9. Now we just add them up. 37 plus 58 is 95. So we have 95/9. For the final step, we ask, how many 9s go into 95? 10 times, with 5 left over, which gives us 10 5/9. Look at that, the exact same answer we got before.
Okay, let's do one more practice round just to really lock this method in. How about we try 8 2/7 plus 3 3/7? All right, let's do the dance. Step 1, convert. 8 2/7 is 58/7, and 3 3/7 is 24/7. Step 2, add. 58 plus 24 gives us 82/7, and step 3, convert it back. We get our final answer, 11 5/7. See, it's a reliable, step-by-step process every single time.
So we've walked down two very different paths, but we arrived at the exact same destination every time. That leads to the big question, right? Which one is actually better? Let's put them head to head.
Okay, so here's the deal. Path 1, the separate and conquer method, is fast, it's intuitive, especially when the problem is simple. But its weak spot is that regrouping step, which can definitely be tricky. On the other hand, path 2, the improper fraction way, is like a tank. It's a super consistent process that always works.
The only real downside is that sometimes you can end up dealing with some pretty big and clunky numbers.
So what does this all mean for you? It means you don't have to be stuck with just one way to solve a problem. Think of it like this. You now have 2 different tools in your personal math toolkit.
And this is probably the most important takeaway of all. There's no single best method. The best method is whichever one clicks for you. It's the one you can pull out of your toolkit and use with confidence every single time without making any little mistakes.
So I'll leave you with this question to think about. The next time you have a problem like this, which path will you choose? Will you be the fast and intuitive separate and conquer type, or the steady and reliable improper fraction type? Now you have the tools to decide for yourself. Thanks for joining this explainer.